All right, so today we're going to kind of bring everyone together, and we want to look at the addition versus subtraction versus multiplication versus division rules. And so for a lot of this is if we just do them individually, it's like, hey, no big deal. But it's when we start letting everyone play together, that's when sometimes the frustration starts to set in. So let's just hit some of those basics that are here and make sure that we're seeing the similarities and seeing the differences between them. So let's go after someone like this. Let's grab 3x plus 2, and we are going to add that together with 2x minus 5. Now, I've got them wrapped in parentheses to show that those are our binomials. So that's a package deal that's there. It's not just a 3x and then a plus 2. It is 3x plus 2. Okay, so the idea here with addition is pretty straightforward. Adding our like terms together, and we just add. So we're going to add the 3x with the 2x, and we're going to get ourselves a 5x. We're going to combine the positive 2 with the negative 5. Remember the addition and subtraction symbol, those are your symbols as in they are positive or negative numbers. Combine those together, hey, we get a negative 3, and there we go. We're all set. Okay, so let's see what happens when subtraction shows up. So if we take the exact same problem, but we change it into a subtraction problem. The issue here is that subtraction carries with everyone. It's 2x minus 5. Remember, that is a package deal. So this subtraction sign does visit everyone. So for some students, they like to sneak the 1 in there to show that it's a negative 1 and then distribute. Negative 1 times 2x is a negative 2x. Negative 1 times a negative 5 is a positive 5. And then it becomes where we are just combining those like terms together. If you can just do the subtraction, 3x minus 2x, all right, and get 1x, just like if you did 3x combined with a negative 2x, you would get a 1x. And then again, if you're comfortable doing the negative 2 minus the negative 5, and that's where I get into the issue of the double negative and I've got to rewrite it. Okay, if you can do it mentally, that's there. It does give you a positive 3. And by distributing the negative 1, I can see the negative 2 combining with a positive 5, and there is my positive 3 that we're looking at. All right, so addition, subtraction. Subtraction, the main thing is, hey, make sure it goes to everyone. Okay, so your multiplication problem. Well, this is your distributive property. For some of you, you've understood the term of FOIL, first, outer, inner, last. Again, if we think of it as just the distributive property, it's going to take care of it. So the 3x needs to get multiplied to everyone. So 3x times 2x, that is a 6x squared. Remember, we are multiplying here. So we multiply the 3 times the 2, and because it's your variables, we are adding those exponents. So that's where your x squared comes from. 3x times that negative 5, negative 15x. All right, now it's time to distribute the 2. So 2 times 2x, that's a 4x. 2 times the negative 5, there's your negative 10. And now we're combining our like terms together. So when we go ahead and do that, we can go ahead and combine your x's together. So the 6x squared is just going to come down for the ride. All right, combine the negative 15 with the positive 4, and we get a negative 11. So it's a negative 11x. And then again, bring down that minus 10, and there we are. Show's over. So a lot more action when it's your multiplication problem. If it's a division problem, well, the thing about it is the only way we can get rid of someone is if it's all the exact same. Remember, it's a binomial, so it does have rep. It's got to match up perfectly. You can't be like, well, I see x's. We can't. I see 2's. No, we can't. That is a package deal. Now, other thing that could show up is if it's a monomial, well, then it's someone who's a little bit different. So, for example, let's grab a 6x, and let's go ahead and put that over a 2x that we're looking at. Now we can do the 6 divided by the 2 and get ourselves a 3. We can see the x's, and we can actually subtract them because it's a monomial. Again, different rules, monomial and binomials there. Anything divided by itself, It's going to be 1, and when you multiply something by 1, it doesn't change it. So that's why a lot of times we see kind of like where we cross things out. Then, yeah, you just end up with a 3 here. So the big thing that we do want to make sure we are doing here is understanding your different rules in different situations. The multiplication versus the division, addition, and versus subtraction. All right, that's it.